Okay, welcome to the last session of the day. I'm very pleased to present Barry Loewer, who's going to be talking to us about beyond laws, beyond space-time. Thanks, Barry.
Yeah, thanks. Thanks to Chris and Baptiste for organizing this great event, and to everybody else who's here. I came here in part to learn, which I think I have so far. Maybe I've been a little annoying, but I have learned some things. And the reason I'm here is I heard Chris give a talk that I found very interesting in New York some months ago about how to think about laws in the context of quantum gravity theories. And I realized, and a friend of mine, I'll even identify, my friend David Albert told me, look, whenever you hear about anything, you say your theory takes account of that. And so I have a view about laws, and I think it fits in very nice. And from what I heard here so far, there's a lot of connections. I hope they come out. But I'm very interested in people being critical of this and seeing what they think isn't right. I mean, I am very interested in criticism, but the book, which is all about, it's already coming out, and I don't want to be in the position that Frege was in when Russell discovered his paradox after the book went to press. But there'll be other books, and Frege recovered. I don't compare myself to Frege, really. Okay, so I also should say I am really jet lagged and a little bit out of energy. So I just want you to read while I catch my breath. This is from the paper by Vincent Lamb and Chris Withridge, where they raise the issue that if there isn't any fundamental space-time in quantum gravity theories, how should we make sense of laws in these theories? Since most of the philosophers usually on the menu that you can easily order up in a metaphysics class, that's where you make your order of what laws you want to give you this menu, they all seem to presuppose space-time in some way or other, in a fairly robust sense, much more robust than we were talking about a little while ago, that Carlo was talking about a while ago. Okay, so that's what the problem is. Now, I have a view about laws. I will give it a name. I'm not sure it's the best name, but it's the one I've been using. I call it the package deal account. I hope it's not a raw deal. I hope it's a good deal. It sort of stands on the shoulders of Lewis's Humean best system account of laws. But unlike Humean's account, unlike Lewis's account, it's not committed to a Humean ontology. And that makes an enormous advantage with respect to doing naturalized metaphysics and many other things. So I'm now going to do a little bit of history, some of which may be inappropriate here, I don't know. It's not like for a metaphysics or maybe an elementary philosophy class, but some things you may know about and not. But when I started writing this book, I got interested in the history of the concept of laws. One thing I noticed is that nobody has written a history of the concept of laws of nature. There's many things written about it, some very good papers by historians of science. Peter Harrison is one, John Milton is another. And there are some good discussions of how Kant thought about laws by Michael Friedman, and a book by Walter Ott, which goes over a lot of different views about laws. But there's no comprehensive history. But the basic story you get out of Peter Harrison and other serious historians of science is that the idea that there are laws, what we can now call laws of nature, which are central to physics and to science more generally, and that they're universal and they're mathematical, and they particularly have something to do with how whatever the fundamental ontology is, how it changes over time. And Descartes was particularly interested in how material bodies move over time. And Newton, of course, picked up on that idea. So Descartes had this dream of a comprehensive universal theory of this sort. You might even call it a dream of a final theory. Of course, Descartes couldn't cook up with it. And I think the dream might have died if it wasn't for Newton, who came along and produced something which did a lot of what a final theory was supposed to do. Of course, we know it isn't such a theory. But what is a final theory supposed to do? It's supposed to have a fundamental ontology, fundamental dynamical laws, and other kinds of laws constraining that ontology. And they're supposed to give an account of how the macroscopic world, the world where we start doing, from where we start doing physics, how that in some way is related. People like to use the word emerge, some like to use the word grounding. Where I live at Rutgers, when I walk through the halls, I hear the word grounding all the time, and I want to shoot the people who use it, because when you really think about it, they don't know what they're talking about. Okay. All right. Okay. So I see I have some people who agree with me about that. Maybe not all of you do, but it's a popular word at Rutgers. What?
I was going to give you a standing ovation.
Okay.
And I think I was going to get shots.
Well, I want to dig a big hole and bury it underground. Okay. So, you know, the concept of laws, we don't have to spend much time on this, had a kind of theological origin, that they were the principles that God sort of follows when he moves matter around. And this was a big change at the time, a big reconceiving of how to do science. And it's usually contrasted with this Aristotelian view, in which the world has a lot of separate systems, each go in their own way, bumping into each other. Sort of Nancy Cartwright's view of the world. She's stuck back in the Aristotelian view of the world. Many good things about Nancy Cartwright, but this is where I would disagree with how to go. Anyway, and in fact, Samuel Clarke actually calls laws God's volitions. But the deity dropped out of laws, although the metaphor of governance remained. And then one wants to know, what is governing? How do the laws govern? What are they doing? So there are some contemporary views about, on the menu, the metaphysics menu. I'm going to mention three. There are a few others, but this is the three main ones. They divide up into two kinds usually. The Humean accounts, for which David Lewis's is the best description. I assume everybody here really knows Lewis's account. I don't have to say very much. But Lewis thought that the world is something like a vast mosaic in a space-time of, he even seems to write as though it's Euclidean space, a substantivalist Euclidean space-time, I don't know how essential that is, in which there are perfectly natural properties instantiated at points. And the laws are theorems of the optimal systematization of the distribution of the instantiations of these fundamental properties throughout the mosaic. And somehow Lewis thought you're going to get the manifest world out of all of this. And he did a lot of work to show how you get some stuff out of it, how to get counterfactuals and causation. None of the ways that he has of doing it really work quite right. But, you know, he's he's the hero, in my view, of the 20th century in philosophy at any rate. Then there are non-Humean accounts. They tend to construe laws in some way as either metaphysically fundamental items over and above the fundamental ontology that in some way governs it. David Armstrong had a view something like this, but the more sophisticated view that I know about is my friend Tim Maudlin's view, in which he literally has laws, are items. In Maudlin's view, they don't exist in space-time, but they govern what's in space and time. And furthermore, they somehow latch on to the passage of time. He thinks of time as not literally as a growing block, but as having an intrinsic directionality. They latch onto that, and in some way they allow talk of one state producing subsequent states, maybe a state on a Cauchy surface or something like that. There's another kind of non-Humean account in which what's fundamental are what's called powers. So I don't know, Alexander Bird, Ellis, and various other people have views like this. They attach these powers to the fundamental properties in some way. So it's a little bit like the Aristotelian Cartwrightian view, but it of course has this problem of what happens when powers clash with each other. What do you do then? I guess you need laws to settle that, but they don't really say much about it. But this is one of the ways of developing a view. It doesn't fit in very well with contemporary views of physics. And by contemporary, I mean from Newton on, where the whole state, laws describe how the whole state evolves over time. Okay, there's some other non-Humean views too, but I don't think any of them is worth carrying on. There are other Humean views also. Okay, so if you, from the very beginning, the idea about laws as the principles that God uses to, the principles that God follows in governing the motions of things, there were two aspects to them. Because God is a mathematician, you all knew that, right? That God is a mathematician, that's what Descartes thought. The laws would be elegant, simple. Of course, Descartes didn't know this, but a little bit later he would have thought there were differential equations. Or maybe he would involve, more fancy mathematics than that. But they'd be relatively simple, and they'd be universal. This is the systematizing aspect of laws. There's also the governing aspect. That's what is emphasized by the Maudlin and the Powers view about laws. I think these are two big pictures of what laws do. There are some people in the history who make this very explicit. Berkeley, interestingly enough, talks about laws as doing both of these things very explicitly, but they can be separated from each other. Because I don't understand governing. Somebody here does. Good for them. Okay, there are two different views about fundamental ontology. One is the Humean view. It involves no necessity in the fundamental ontology at all. Nothing which plays anything like the role of necessity. That's Lewis's view. And the non-Humean view, which allows the fundamental ontology to have necessary connections, their instantiations to be necessarily connected to each other. Necessity there being a very strong kind of necessity. Some things what people call metaphysical necessity. Now it's interesting that one could separate these two different divisions, and one can hold on to a systematizing account of laws while rejecting the Humean ontology, and that's exactly what the package deal does. Okay, back to the problem. The problem is that, as I understand it, all of the ways of pursuing a fundamental account of the world, which can combine general relativity with quantum mechanics, make for a quantum gravity theory, involve views in which space-time are not fundamental. But all these views about laws make reference to space-time in the way you characterize the account about laws. Now you might try to hold on to one of these views and sort of modify it to hold on to accommodate that by having some sort of arena in which they operate, which is different from a space-time arena. I'm going to do something like that, but not exactly. Okay, so everybody got what the problem is. This is the problem that Chris's and Vincent's paper is about. Okay, so I'm going to tell you now that the package deal account overcomes these problems. And in fact, it overcomes another problem too, which is what attracted me to the idea, what made me hit on the idea. I never liked Lewis's perfectly natural properties. He has a bunch of things that perfectly natural properties are supposed to do. I'm not sure what's essential to them or not. They're sparse. They don't have necessary connections to each other. They can be recombined in all sorts of ways. Maybe they're reference magnets also. Maybe whatever that might be. Maybe they also form objective similarity. And they're also supposed to be what physicists are in the job of discovering. But it's not part of what perfectly natural properties are by their very essence, is that they're what physics would discover if they followed the methodology of physics. I want to invert this. I'm going to say what the fundamental ontology is what physicists would come up with if they were to follow the methodology of physics to the limit, if they were to come up with anything. And in fact, they might come up with more than one thing. So my view is going to allow for the very odd conclusion that the fundamental ontology of the world might be multiple. There might not be one fundamental ontology of the world. Some people don't like that. People who have a building block conception of metaphysics don't like that. But I don't think they're buildings, ones that the buildings are going to fall down in the nearest earthquake anyway. So, okay, I'll try to stop my metaphors right away. Okay, not helping me. Okay, so how does the package deal account do this? So it does this by saying what you get by systematizing is you've got to get the ontology and space-time and the laws all together. But what's the obvious question? If all of these come in the systematization, what's the question? Well, what are you systematizing, right? That's the obvious question. Okay. Okay. My answer to that is inspired by Quine, really. Oh, well, just a quick remark here. One of the things I noticed from looking at some of the literature here and remembering something that Nick Huggett sent me at one point is the question of a dispute within the space-time literature of which comes first. Are there space-time symmetries there first and the laws are supposed to match them? Or are the laws there in some way, the dynamics first and the space-time symmetries come out of the laws in some way? The view I'm going to give here says neither. They come together. So I think a cute thing about this view is what it says about that. I'm not sure settling is the right word, but it says about that. Okay, so what gets systematized? Well, the answer follows Quine's view that science starts in the macroscopic middle and proceeds by adding ontology and laws that systematize the macroscopic middle, and more ontology laws that systematize whatever gets added at that point, and more and more and more and more, until we get, well, maybe we get to causal sets, because maybe causal sets turn out to be the best way of systematizing general relativity and quantum mechanics into a quantum theory of gravity. Of course, if this is really going to be part of metaphysics, whatever is added, in some sense, has to be in the world. And I'm going to have to tell you something about what I mean by that in the end. So, of course, as science developed, they might add something that looks like it systematizes pretty well, like phlogiston. But that would have been a mistake, because it's not there, really. It also might be that science, as it advances, adds stuff that is just a gauge. It's not really there. Okay, so this has to be worked out. Ultimately, the world has to answer as to what's really there. But science, the methodology of physics, is our best take on that. Okay, so I hope what I just said is enough. Now, maybe causal set theory, once it's really worked out, as we can see from the discussions earlier, it hasn't been worked out. And in particular, one of the big issues are, well, for me, the issues are, let me see if my next slide is about that. Well, let me continue this and I'll go to that side. So new ontology and quantities may be needed to systematize the old ontology and properties. So systematizing the motion of macroscopic bodies might require adding microscopic ontology, unseen or even unseen macroscopic ontology, unseen microscopic ontology, and also unseen macroscopic ontology, and quantities, and an account of how the new ontology and quantities relate to the old ones, and an improved systematization of both. But you really need an account of how they're related to each other. Sometimes people call that relation emergence, sometimes they call it grounding. I don't think I'm going to have time to tell you what I think should replace grounding, but maybe that might come up in discussion. Okay, so you get the idea the ontology is a part of the systematization. Another person who has a view something like this, but it's radically different in the end of the day from mine, lives nearby on the other side of some lake that I drove around. This is Michael Esfeld, who I thought might be here. But he also thinks that a lot of the stuff we talk about in the ontology is just part of the systematization. But unlike him, I'm not taking particles as a priori fundamental in the world, if that's the right description of what he does. Some of you might not know about it. He calls it superhumanism. Maybe I can stop to tell you something about that. Everybody here know about superhumanism? You'll know because he's a neighbor. My experience with Michael is this. I don't know what he would say about this, but I met him a long time ago. Could be as much as 25 years ago, in which he was giving a paper defending some sort of dispositionalism about fundamental laws. And we spent all night arguing about this. I tried to convince him to be a Humean, because this was before the package deal account. I was a true blood, best systems, Humean kind of guy then. So, okay, I tried to convince him about it. And the next thing I knew, he became not only a Humean, he became a super-Humean. Okay. Now, I don't know if that's the way he thinks about it. And I realized what he did is he produced a reductio of my Humeanism, which is part of the reason I went to this package deal story. But there are similarities between them. And in this book I wrote, I have a long discussion of what I think is right and wrong about his approach. Okay, so there's a kind of march towards systematization. To systematize macroscopic events and properties like temperature, weight, density, physics adds microscopic ontology of particles with quantities like mass and charge, distance relations between them, and ultimately they're going to end to deal with them. We're going to add quantum mechanics, however we want to think about that. And I gather the right thing to say in this way is just to say we don't want to say anything more about how to understand quantum mechanics. Is that the right thing to say in this group here? Good. Okay. I have a lot more to say, but we don't. That's only dinner. Okay. So the march continues. You understand the march? It's like this forced march of physics, adding ontology, modifying the arena more ontology, more quantities, march. Maybe it comes to a stable point. Maybe the march can divide up and end up in two different marches and two different good accounts. That's a possibility. So here's where things sort of stand as I understood it in contemporary physics. The ontology and laws of quantum mechanics are not clearly settled. There's quantum theory and general relativity. Quantum theory and general relativity do not fit together very well. And so there's no completely successful accepted quantum theory of gravity. So we want some fundamental ontology which does that. And a few ideas. Now, most of the discussion here has been about causal nets. Who here's a loop quantum gravity person? There are such people. I mean, the person I know, but I haven't talked to him in a long time, is, I don't know if he still is Lee Smolin. He's a big loop guy, isn't he? He's in the loop.
Yeah.
But I'm pretty much out of the loop. I talked to him about it, but
He's a loop guy, but he has not been in the loop.
I see. Well, he definitely is a strange guy, but I've known him for a while. Long time, actually. Okay. And there's the causal set theory, and most of it is about that. And that's an ontology I'm beginning to understand and kind of get a feel for and like. I don't quite understand what exactly the kinematics is. Some of you, I think, understand it perfectly well and can explain it to me clearly and even give me something to read about that. I don't understand what the laws are that are over and above it but there'll be some sort of account of both of those things. I think the big issue here, here's the slide I wanted to put on, is the issue that most of you think about. It's the issue that's beyond, I would say it's beyond my pay grade, but I don't want to say that too loud because Rutgers pays very high salaries. undeservingly, really. This is the really important issue. It's what most of the discussion here has been about. What exactly are the ontologies in the fundamental quantities, if any? Maybe these are just bare events. And the kinematics and the laws. And how do you get quantum field theory and general relativity out of them? And how do you get something that will apply in the neighborhood of black holes in the early universe and so on? That's the really important issue. My talk is about a much less important issue. But it's less important, but it was important enough for Chris to write about and get me here, so maybe that makes it important. But I think it's much less important than that. Okay, so they point out, let's just say, I don't know why I'm calling them L and M here, but
L and W?
no idea why that's there. But anyway, maybe L is W. Lamb and Woodford, maybe the M is a W. Yeah, it came out upside down. Everything is backwards. Anyway, they point out that each of these is incompatible with Lewis's Jungianism at any point. And also with just point that, look, all of these seem to involve these fundamental elements being glued together in some way. They like to use the metaphor of glue. Okay, now I was a little bit puzzled about that because Lewis has glue too, really, because he has the structure of space-time. And it, of course, has glue in it already. So I don't know that he'd be so upset with having an arena with this glue in it. But it is a remark to go along the way. If you wanted to, maybe...
That's what we mean. You need some sort of
Glue.
without it being nomically charged.
Right, that's right. Yes, good. And Lewis has that in his account. And what nomically charged is an interesting question, too.
What does nomically charged mean, if you don't mind?
That's the question for him, not for me.
It means that there's something like necessary connections at the fundamental level, something that Hume didn't want to have.
So Lewis kind of has that too, doesn't he? And Hume has that too, I guess. It's because he has space time, so I guess they have it too. But so they must mean something more. The only thing I know about charging is that the only way I get through Europe is using my charge card, and that's what I know what good charge. Okay, so I can sort of imagine how if you were a dyed-in-the-wool Humean, you can reinterpret the ontology of these connections as compatible with something that sounds more like Lewisian Humeanism. And I think they do something like that a little bit, but I don't want it to quite go that way. They also point out that the non-Humean accounts have trouble with with causal set theory and quantum loop theory because they seem to presuppose fundamental time and directionality of time. Now, one of the things that I'm still very puzzled about is it does seem to be some sort of fundamental birthing process that's, we heard a lot about that earlier, that's associated with causal set theory. One thing gives birth to another, and before you know it, you've got a world there, I guess. I guess that has a directionality in it. I don't know whether to think about that as time or not. For me, to have time, I do think there's time, but not fundamentally. I don't think that there's time fundamentally. I'm a block universe kind of guy, ultimately. And what I do think is that time and its features have to emerge from something more fundamental. I'd like to get the directionality more closely related to some things that have been brought up here earlier. That is sort of the wiggling idea, that you wiggle something, and when we wiggle something, we make a difference in one temporal direction, but not in the other temporal direction. And that's where the temporality comes from. To work that out, I think, Woodward, for example, doesn't work that out. He just takes that on board and assumes that. But I think it can be worked out from statistical mechanics or something along those lines. Anyway, I think the package deal account can come to the rescue of all this. Because it says, look, the arena that's fundamental, and the ontology in it, and the laws, well, the arena doesn't have to be anything like space-time, and the laws don't have to be those of relativity or of quantum mechanics per se. They could be those of causal set theory, and the kinematics can be those of causal set theory. As long as what they do is they systematize their ontology, and they come with an account of how the other stuff is related to that more fundamental stuff. How it is, as they like to say, grounded in or emerges from that more fundamental stuff. And that's it. I mean, I could have given you my paper in 2 minutes, but it wouldn't have been worth coming. But that's my story. So why does the PDA work? Well, according to the PDA, laws are entailments of the axioms of the best systematization of the world. And that best systematization is going to include ontology, together with space-time, together with laws. And what it's going to systematize ultimately is the macroscopic world. That's where we start. And anything else that gets added along the way on the march of systematization. Okay, now I'm invoking metaphors there too, but I hope they're sort of comprehensible enough to see at least what I feel about it. So that's why the PDA, it works. In a way, it works so that there's no a priori metaphysics in here. What I don't like about Maudlin's account is that he has a priori metaphysics. You've got to have this temporal directionality of time. In fact, he uses it to rule out some of the solutions to general relativity, where you have causal loops. But I don't think a philosophical account of laws should be in that business of ruling out things that physics allows for. And I can give many other examples of this, but I think you all sort of see what's going on. The PDA doesn't work like that. And so far as I could say, as an account of laws, the PDA should work for anything that we'd ever want to call laws. Now, Lamb and Utherich, Vincent and Chris, briefly consider something that you might mistake for what I'm doing here, but I want to make clear that it's not. They think of something that is an epistemic route. The PDA is not an epistemic account of laws. It's a metaphysical account of laws. There's a metaphysical fact about what the fundamental macroscopic properties are. Of course, macroscopic properties is vague, but modulo the vagueness, there's a fact and matter about what they are and where they're instantiated throughout whatever the space-time arena that emerges that we think of as the macroscopic world. Okay, there's a fact about them, and there are facts about whatever it is about the ontology and the systematization of it that gets added along the way. So this is metaphysics. It's not epistemology. Okay. So they fear, at the end of their paper, I really like the way their paper ended. They fear that when you take quantum gravity into account, maybe we'll have to abandon the concept of laws. Now, I do think we'll have to reconfigure it a bit, because none of those views that are on the menu will work. But I do think the package deal account will work for what will count as a law within quantum gravity theory, or so far as I can see, pretty much anything else. Now, about one other thing, and this is what Chris's paper was really about. The PDA specifies the laws of a world that, like the worlds of the actual world, has a macroscopic description and can be systematized. But what about worlds that have no macroscopic description, either because they are too simple or too chaotic in terms of our macroscopic concepts? Well, there are. There might be, in some sense, a possible worlds that are like that. I think the right thing to say is, this account is not made for those. If you think there are worlds like that, if you're a Lewis realist about possible worlds, or you conceive of them, good for you. But we don't want an account of laws that applies everywhere. We're not doing analysis. If we're doing analysis, we want an account of what something is that applies under all, in some sense, conceivable circumstances. that's analytic. But that's not what we're doing here. Okay. I didn't say what Chris's thing was about. When you come to the fundamental ontology, suppose it's the causal set theory, then you'll have certain constraints that are given by the kinematics, maybe, and the laws. And even if there are necessary connections, it doesn't mean that they can't be recombined to make other possible, physically possible worlds, say laws compatible with those constraints. And it might be that from some of them, space-times as we understand them emerge, and for some of them, they don't. So I agreed completely with your story about that, but the details need to be worked out, as I think you were making clear. Also, so this account allows for a sense of physical possibility, but it does not give an account of metaphysical possibility at all. Because I think metaphysical possibility should go the way of grounding, but that's really a whole other story that I get into a lot of trouble with if I were to try to pursue that, since a good deal of 20th century metaphysics has been people talking about metaphysical possibility. Okay, so that's my conclusion then, is that there is an account of laws, the package deal account. It's a metaphysical account of laws. There might be questions about it, but I think it's coherent. And it can accommodate quantum gravity theories, and I think anything else that physics might cook up. Okay, thanks.
And some comments from Zito.
So I have the only seat here, so I'm going to depart. But I may have to give you this thing.
Do you want me to bring another chair up?
No, I think I will use the...
So I can stay here?
Yeah, I think you can.
Okay, yes.
Maybe we should take the microphone.
Yeah.
Thank you.
I have to...
Okay, thanks.
Okay, so thank you so much. That was very interesting. And I just have a couple of questions just to understand better what you have been suggesting with this package deal account. So the first question is kind of a general question, because, so if I understood correctly, you reject the Humean ontology, meaning that your laws, which try to systematize the macroscopic ontology, so the everyday world we see, might be charged with nomic voltage. So meaning that you allow some necessary voltage to be attached to the laws.
I would go nomic, but yeah.
Okay, so let's just imagine that we have like a tree, and we want, so this is our macroscopic reality, and we want to understand why apples fall, and then so we introduce the gravitational field with some laws, and then we want to understand the gravitational field even better, so we go to the quantum gravity laws, which add some ontology, which might be, I don't know, strings, loops, or causal sets, and so on and so forth. And so my question was like, what is exactly the relation between the laws and this micro ontology that they add to the picture, and how this all reconnects with the emergence of space-time, or so how this connects with the fate of space-time in the more general picture. So does it, I don't know, force the existence of space-time, or can we assume other views on space-time? And then the second question was, like how, because, so how do you consider probabilities? So how probabilities enter into this package deal account? Because, I mean, probabilities for sure play an important role in quantum mechanics, but they're also important, for instance, within loop quantum gravity. If you take the covariant approach, you there have probability amplitudes. And I get it that I mean, there are still a lot of doubt. There's still a lot of doubt about how to interpret probability amplitudes, because you cannot use the normal like Pack integral method to interpret them, because you do not have like time. So yeah, it was just another general question about how would you interpret probabilities in your account. So I will just write like probabilities. And yeah, these were my two main questions, just to clarify a bit.
That was a great question. Can I say something about them? First of all, I'll try to be very brief so this discussion. The second question is my all-time favorite question.
Okay.
The first question.
Oh, wait, maybe I just give you back this.
Okay. So the first question is, what's the relationship between, let's say, particle, statistical mechanics, and, things like ice cubes melting and gases expanding and stuff like that? Well, we have some story to tell about how it is that when you get a whole lot of particles moving around in such and such a way, and they conform to classical mechanical laws, you got an ice cube there at a certain temperature. And there's an account of how, if it's in the air, after a while you get a puddle of water there. Okay. Now then when it comes, so that's the relationship. Now that's what sometimes people call grounding. Jonathan Schaffer wants to have special metaphysical laws that connect them. That's because he's a metaphysician. He wants everything to be metaphysical. I don't think you need metaphysical laws there at all. I think the way we understand what particles are is we understand the theoretical by their relationship to the macroscopic that we start with. So what it is to be a particle is it to be the smallest bit of an ice cube, or things like ice cubes, and so on. And what is to be mass is in part something that's ultimately going to play a role in the theory, but also to make up things given account of the weight of the ice cube and so on. Then, of course, we can go a little bit deeper, because you just don't have particles there. They're really molecules, and they're combined, and there are quantum mechanical laws about how they combine. So there'll be some account of how hydrogen atoms and oxygen atoms are in quantum mechanical, can be in states such that you can form a state which is a water molecule. I'll get a little tongue-tied if I go into details about that, okay? It's a little complicated to give an account of chemical bonding. I can give an account like that, but I would be better off leaving it to physicists here to really tell a good story about it. Okay, that's the picture I have in mind. And instead of having grounding being the connection, it's rather that we understand what the more fundamental is by its connection to the less fundamental. You won't need grounding relation then, because what it is to be the less fundamental will be the kind of thing which makes for the less fundamental. Now for your other question, I don't know if you find that satisfactory, but that's what the kind of answer I would give to your first question. Probability, I think, is not part of the world. Here I agree with Lewis, and I guess with Esfeld too, but I think Lewis showed the way, though he wasn't the first. I would put it this way. There are no probabilities in the world fundamentally, just like there's no causation as such in the world fundamentally. What there is we introduce probability as a way to help us systematize the world. And probabilities are introduced because why? Well, suppose the world consisted of the outcomes of coin tosses, HTT, HT, HT, HTT, HTT, HT. And that going on for a while, such that it looks you know, we can't find an algorithm to describe that long sequence very easily. But we notice that subsequences all have a frequency close to a half, and so on. And so we say, well, we can systematize that sequence by saying that the probability of each event is a half, and the events are independent of each other. That's what probability is. I think this idea has a lot of legs to it and can be used to make a lot of sense of probability. Lewis sort of suggests this idea. He just didn't, it's like somebody discovered gold, the Ring. I just saw the Ring operas. You all know them probably, right? Wagner operas, the Ring operas. So you know in that opera, the giants, or the giantess left, has the ring. In fact, after that, it mattered, even Siegfried got it at some point, but he doesn't know what it could do. I think Lewis didn't know what his account of probability could do. So he connects it with dynamical chances, but his account doesn't his account is completely compatible with deterministic dynamics, and so on. I think this is a great, great idea, and it's one of the other things that I really work on and like, and I think it's really needed to give an account of other probabilities in quantum mechanics and in statistical mechanics, and I think that it's needed to give an account of causation based on the wiggling idea that Woodward likes, and so on. So that's why I really liked your question.
Let's thank Charles. Okay, questions. All right, start with Lorenzo.
Yes, I really like the idea in general. I was intrigued by some parenthetical remarks that you made about the possibility of having more than one best package.
Right.
Best system. And it seems to me that in a sense this is going to be inevitable because there will always be cases like that. But from trivial ones, you can either take negation and conjunction as primitive or negation and disjunction and write something completely equivalent. Two cases, more complicated ones, in which you seem to have different axiomatic systems which are in some sense intertranslatable, something like that.
Right.
I wanted just to ask you, is that what you have in mind there? Or in general, how does your view of law take into account theoretical equivalence?
Okay, so I also think that's a great question to ask about. I think that there are two somewhat different parts to that. Okay, one is the general question about theoretical equivalence that you ended on. I think that's a big open question in the foundations of physics. Everybody can think pretty clearly about empirical equivalence, at least once you fix what's empirical. But we all think that there are stronger notions of equivalence, but we think there's still some differences. So we still think that there are some theories which are empirically equivalent, but that they're really different theories. And there are other theories which we think are empirically equivalent, but they're not different theories. I happen to have a graduate student now writing his dissertation on that subject. Jill North, who who was mentioning Jill just earlier? She was a former student of mine. She's written about this now a colleague of mine, this very subject. And I do think she has a very strong view about differences. I could say for her, Lagrangian and Hamiltonian mechanics are different theories of the world. I don't see that really, but I do think, as an example, there are some people who think, maybe if I'm too long-winded, just who's chairing this, just say, shut up. Okay? Because, I mean, you're asking questions just in the things I'm thinking about, so I really appreciate it a lot. So here are two versions of quantum mechanics that I kind of like. I kind of like the general Bohmian way of approaching quantum mechanics. Not Bohmian-specific way of doing it, but the idea that you have something like that the wave function corresponds to, maybe it's more lawful, like Shelley Goldstein and Tim Maudlin think, or maybe it's a field in a high-dimensional space, like David Albert thinks. People who know what I'm talking about, you're all familiar with this. Okay. These seem to me to be really, really different. Okay. They're empirically equivalent, for sure, but they're really different theories of the world. And this is not a matter merely of gauges. I think, in the sense when you can discover that it's just a gauge, in the very simplest case, it's because we can find a mathematical way of sort of dividing it, getting rid of the gauge. And we do in the most simplest ways of measurement theory. And we can do that in more complicated places. But it might be that our mathematics, the tools of mathematics that we come to the world with, just doesn't allow that in some other situations. And the laws that we want of the world, we need, they have to satisfy, and I didn't say this in my talk, I just left it out, the criteria on a good systematization. Of course, that comes from, and Carlo brought this up earlier, that comes from the history of physics. And they are evolving over time. And who knows what will happen with them. But they're very much evolved in connection with mathematics. And mathematics has developed to serve the needs of physics, but it goes its own merry way, too. And then maybe physics can say, some of the things that mathematics went, we can make use of that as well. So I don't know what to say. But what I do think is this. It certainly is possibility that physics goes along and it reaches something like a resting point, a point such that we have a systematization that satisfies all the criteria that physicists lay down on what the laws are. But there are two accounts, and they say that different things are fundamental. Now, your example from logic, of course, nothing in logic tells you that and should be fundamental and or shouldn't be, okay? So that's a really trivial situation. But the world might be such that there's more than one fundamental account. So what does that tell you about the world, reality, the cosmos? The cosmos itself, and I kind of think this must be related to ideas from Eastern philosophy, and maybe Faye can, where's Faye? Oh, there you are. Maybe you can have some direction since you seemed, I've read the Abhidharma and I thought, wow, but I couldn't think of anything more than wow when I read it. Okay. And I like Buddhism from practice, but I don't know it in theory very well. There's an idea that is the cosmos, but what counts as fundamental and what counts as laws, that in some sense comes from us. Not just from us. So this is not relativism or irrealism that I'm advocating, okay? But it comes from partly us and it, because not anything will count. But there may be more than one way, like logic does. Maybe an and can be made as fundamental and always. But that's a really good analogy, and I hadn't thought about, as simple and obvious as it is, I hadn't thought about using it, but I will.
Tim.
Thank you. So this is a two-step question. The first question is as follows. So you made it very clear that this is not supposed to be an epistemic account of laws, but in a sense you want to claim very much in the Humean spirit that for something to be a law is really nothing over and above showing up in the best systematization.
Correct.
So the first part of the question is, do you think about the ontology in exactly the same way? So would you say that for there to be electrons is nothing over and above something like electrons showing up in the best systematization?
Yes.
Okay. Then the second part of my question is, why? Why is that part of the, why do we make this a package deal? Because it seems at first sight there is an alternative way to sort of safeguard something like a Humean account of laws without committing to this view about the ontology. Because you could say something like the laws are just whatever best systematizes the fundamental ontology, whatever it turns out to be, without committing to the ontology being some sort of natural property sprinkled over a mosaic.
And that fundamental ontology might involve necessary connections.
Maybe.
Maybe. you could take that route as well. So Heather Demarest takes that route, actually. Why? Well, you know, you follow the route, you think of something, and you follow what you think of. I also think it's better to go my route, because I get the space-time in mind, too. And I get these other things like alternative fundamental ontologies. And I think that's a good thing, not a bad thing.
So could you explain what you mean by you get space-time too?
Yeah, space-time also is part of the best systematization. It's not something that's there first. What's there first is reality. And it gets systematized in the ideal end of physics systematization, maybe as causal sets, out of which emerges our more familiar macroscopic space-time. But I think that's a good question. And I do think I'm suggesting something more strange than the route that you were imagining taking. And I do think I should think more about why you should go in the strange. But, you know, philosophers like the strange, as Chris was pointing that out earlier, I think.
Thank you. I have two questions, but maybe I should start by asking one, then get to the bottom of the list again. So my question has to do with the non-actual possibilities. It seems to me that you concede quite a lot to the Lewisian when you accept that there are such possible worlds and that your account in general will not be applicable to those.
No, I didn't concede that there are such. I said if you like them, good for you.
Okay. I see. Okay, good. That's helpful information. So you don't concede that. You don't think there are such.
No, here's a big question, I think, in philosophy of physics. To what extent does physics need a notion like metaphysical necessity to really make sense of physics? And Quine thought it didn't need it at all. Obviously, we want to have some notions in which there's what you were calling nomic voltage. I think it's some sort of voltage. I don't want to use the word nomic there because it might not be what I want to think of as connected to laws, but this might be just terminological. But you do need something. You might want glues, and the glue might be constructing the arena. It might even be constructing conditions on the occupants of the arena, like fields. For example, in quantum field theory, I think many people think that you can't have, a Higgs field without having a whole lot of other fields.
Right, but here's a reason why you think you might need something like, going beyond, the physical possibilities, because you might want to make sense of talk like, this particular quantum theory of gravity could have been false. Sort of counter-legal terms, or issues like that, or had such and such true theory turned out to be false, what then, kind of? Because if you don't, then if you don't accept the wider range of possibilities, it's kind of unclear how to deal with questions like that. Maybe you want to have some way to do.
Well, of course, before you have the theory, there are a bunch of views on the table, and you can think this one might be true, that one might be true. That's an epistemic possibility. You're wondering about a metaphysical possibility. I do agree we sometimes want to talk about them, particularly we could talk about counterfactuals. What if the gravitational law was an inverse cube law? What then? I don't think anybody, I'm now going out on a limb because I haven't really studied this. I've wondered about it, and I've wondered about doing a literature search to see if somebody can tell me whether anybody has actually come up with such an account. Because Lewis's similarity account to counterfactuals looks like it can sort of be made to fit in with that. But what's similarity here anyway? Okay, my account of counterfactuals will not extend to that. So I don't know what to say about that. So it's a good question.
I wanted to ask a question about the macroscopic middle. So I can see why you need something to systematize, and I can see why you take the macroscopic middle and try and build outwards. But I guess I'm not sure about where you make, like what motivates or justifies the choice of macroscopic middle. Because it seems like you could take any arbitrary portion of the world that you might want to, like, as your starting point, and then systematize out from that. So why is this sort of macroscopic middle the special thing to use for systematizing? Or is there something else you could do? Something like, well pick the scale that gives you the best systematization of the other scales, or something like that.
Well, being macroscopic does seem pretty important to the history of physics, doesn't it?
I mean, some of physics, but I'm not so sure about the recent stuff, I guess.
No, of course not, but the recent stuff is stuff that they got to as part of what's systematizing the macroscopic, right?
Yeah, but like once you got there, like why not take, I don't know, like a different scale, and if it gives you a better system, like why maybe it's a sort of like
that'd be
ladder
great.
You can kick
It
away
may give you a better system,
Yeah.
but it won't give you. It's supposed to give you a better system at that level, but it won't give you cats. If it doesn't give me cats, I don't want it. I have a pet cat, and for me, cats are essential to the universe.
I mean, I was thinking it could give you cats. Like if
Well, if
you
it
can
does,
systematize in sort of like both directions,
then maybe it is systematizing the macroscopic. Then that would be fine.
Okay.
As long as it gets the macroscopic back.
You don't have to start with the macroscopic. You can
No,
start
but
with anything as long as it gives you the best
Sure,
system.
as long as it gets the macroscopic back.
Okay, good, thanks. Klaus.
Yeah, thank you. This is also related to probabilities. And the first part of the question is, I mean, do you still believe, or Lewis believed in his 94 paper that, I mean, this you mean best system account can be seen as an interpretation of probabilities?
Mm-hmm.
And this is also, yeah, okay. Then here's the question. I mean, there's something with probabilities like the space-time. I mean, Lewis assumed this kind of ontological space-time, and then that was to be systematized, and this is a kind of problem. Now, in the 94 paper, he allowed that the best system has a probability in there. It's uninterpreted, but later, I mean, we try to fit it to other frequencies, and then we get a best system of the world probabilistic statements, and their probabilistic laws, and we have objective kind of probabilities, right? But, I mean, not the same thing might happen, and has maybe already happened, because probabilities might not be the right thing. I mean, maybe we should think about quantum probabilities, because there's no better. Or, I mean, this morning, you showed this picture, and you asked what are the probabilities, and maybe we need different kinds of things here. So, might the same story that has happened with space happen with probabilities?
Yes, I've thought about that just a teeny bit. So, the place where I thought about it is a bit different and not as exciting as where you were thinking about it now. So, there's a dispute among the people who write about statistical mechanics as to whether you use typicality or probability as a fundamental notion. And they get probability out of typicality, whereas I'd rather go the other way around. But maybe you'll ask for which is the best way of doing systematization, and maybe they're both perfectly fine, because they're both tools for systematizing. Maybe the ultimate thing for systematizing are some sort of measures which do not satisfy the axioms of probability, but along the way you get probability out of it. That's what you're suggesting. That's a great idea, I think. I just hadn't thought about that.
Faye.
Yes, thank you. Thanks, Barry. One thing that appeals to me about your account of the package deal account is that it seems to treat both what you call ontology and laws together in this package deal. And I think it's, if I understand correctly, then we may call those things kinematics and dynamics. I'm not quite sure, but possibly ontology for us. I mean, when we say the word kinematics,
right? I sort of understood it as sort of getting rid of that distinction in quite that way. But but I think I know what you mean.
So the appealing thing is that it seems one appeal to me is something that one might hope for in the future, which is some kind of breakdown of the distinction between those two things, so that there isn't so much of a distinction between the stuff and then the laws, or for us the kinematics and dynamics, and that they somehow become more intertwined with each other, or even fully unified into one concept. So, do you have any ideas about how that?
Thanks. No, I think that's.
Might proceed, or
well.
You can see a way to. Because I have to confess, I can't see a way to doing that at our current stage of development. For example, in causal set theory, but I would hope for this in the future.
I intend to spend. I have a lot of things I'm trying to do, and I don't know how smart I am or other constraints I could do it. But causal set theory is relatively new to me to really understand what's going on, as you could tell from my questions here. I do agree with you. My one thought about it is that, of course, what I was interested in is coming up with a philosophical account of what laws are that allows for what you're talking about, but not for really telling you how to do it in a particular situation. But what about this? Just think about disputes you often hear people get into about classical mechanics. That I understand well, because I remember my class in graduate school in classical mechanics, actually. Sometimes you see people talk about mass as being what it is in virtue of its connections to the laws. Sometimes you think about it being talked about the way Lewis wants to think about fundamental properties, as being independent of the laws. So that you could have worlds where there are masses, the property of mass is instantiated, but it doesn't satisfy at all the classical mechanicals or any other particular laws. That would be Lewis's view about the perfectly natural property of mass. Whereas other people have the view that it's essential to the property of mass that it satisfies the laws. The package deal account is sort of making that, and I hadn't thought about it except for your questions, that's sort of making that a gauge. Okay? That nothing in reality is going to say it's one way or the other. We could go either way. I don't know how that's related to the kinematic dynamical distinction, but it's made it sound like it might be. Okay.
Just a comment on what you say. One is simply that, as a physicist working on the project, trying to build a faculty of gravity, I find your view of the problem something in which I find myself at ease. I recognize this makes sense as a perspective.
You're saying my view makes sense?
It makes sense for me.
That's only because you're a physicist. That's just because you're a physicist. When I give this talk to a bunch of philosophers, they'd usually say, that's interesting, but it doesn't make any sense. Okay, sorry, Carla.
That's maybe exactly what I'm saying. That's exactly what I'm saying. Various aspects of it. For instance, this view of laws that you refer to is the one I find myself more confident. Something I appreciate in what you're saying is that you sort of schemed a couple of times and then came back. A quantum theory of gravity, in one way or the other, has to be a quantum theory. And we're confused about just quantum mechanics in general. So it seems to me that a lot of the confusion about quantum gravity, it's a confusion about quantum mechanics, just replayed in the context of in which quantum think instead of being a pendulum of gravity.
Right.
And as you said, one way of making sense of it is just to pick or choose or adopt one of the possible ways of viewing quantum mechanics. We talk about Bohmian.
Yes.
And think about quantum gravity in that context. And I think that's unavoidable. I don't see a way to avoid that. To avoid that. I'm not a big fan of Bohmian mechanics. Let's say the Bohmian interpretation of quantum mechanics in particular, for reasons that probably you've heard hundreds of times, so I'm not going to repeat. I think it's not particularly particularly suitable for quantum gravity. I think others might be more suitable. But I think that every philosopher who thinks about quantum gravity shouldn't just think that, oh, space-time is a little bit different, and they treat it as a classical thing, which is less space-timey than it just the real interpretation problem for quantum gravity can't be because we have superposition of space-times or whatever replace them. So there might be coherent ways of thinking about the quantum theory of gravity. I believe there are. I'm not sure the good Lord agrees and create the world in that way. But that has to be brought in, otherwise we're not talking about it yet.
So, if I understand what you're saying, it's this, that look, it would be good if you're going to try to construct a theory of quantum gravity, to first get clear about what you want the ontology of quantum mechanics to be. That certainly seems like really good sense. What it brings to my mind, and I wish I remembered what he was telling me about it, is, you know, Radi Tomolka has worked a bit on understanding quantum mechanics in various circumstances, both in Bohmian mechanics, how to extend it to quantum field theory, and in GRW theory. And I think I remember him saying something about how understanding it in GRW theory fits in with ideas in quantum gravity better. But I don't remember what he said. Okay. More. You don't know what I'm talking about, though.
I know, but I would disagree.
You know, we disagree. So I don't even know. I can't disagree because I don't remember what he said. Okay.
Faye, you wanted to follow up?
So it's not a question actually, it's just a suggestion. I mean, I know that the timetable is packed and the time that we're not scheduled for discussion, people want to go to the spa and everything, but we've been kind of talking around quantum, the interpretation of quantum theory as appropriate for quantum gravity, and we have loop quantum gravity experts in Carlo and Francesca, and we have Sumati and me from causal sets, and I wonder whether it wouldn't be an idea that organisers can immediately reject as being ridiculous and not what people want to do, is to actually just have a little session where we sketch out very briefly what our preferred interpretation is, and I'm very aware that, you know, the two of us have really skirted around that issue. What are we talking about when we talk about a quantum world, you know, quantum causal set world? What's the real thing?
So
I don't know.
I'll let Baptiste and Chris
Yes.
think about that for
Right.
a moment. We've got a couple of other questions,
Yeah,
so we'll
sure.
get through that
Yeah,
and then we can circle back. So Sumati, you had a question.
Just very quickly, just wanted to say that this choice, so this combining of the kinematic or the ontology of whatever this thing that replaces space-time with the dynamics, it's related to some of the points that I raised earlier, which was that depending on that choice of ontology, you may not have all the options open. As you said, I think Gil or Jill, somebody who's worked on the inequivalence between the Lagrangian and the Hamiltonian perspective. These are the kinds of choices one has to make, depending on what you start off with. So I think that there is a connection, there is sort of within this, I think somebody else brought this up, but I just want to make a statement that in causal sets, you don't have access to the Hamiltonian perspective because of the non-locality and so on. And so
right, no differential equations,
the natural thing to do is a path integral. So in a sense, there's a choice that's made depending on what you pick. And of course, there could be other things that you pick for your fundamental ontology, which allow you to do both things. But in certain cases, you don't have those choices. There's already a tie-up between the kinematics and the dynamics, the choice of the kind of dynamics. That's all the statement. Yeah.
I see that. So that's within the discussion of how to best systematize. That's what I said is beyond my pay grade. About what was just coming up, though, is I gather that most people who are general relativists and do cosmology, like an Everettian account of quantum mechanics. I would too if I really thought I understood how to get the manifest world out of the Everettian account. But I don't think you can make sense of probability within an Everettian account. So, you know, you're sort of caught between a rock and a hard place here. Making sense of the manifest world, that's something I think is non-negotiable in physics.
Chris, did you want to have your second question?
Yeah, let me try to be brief. I was a little bit puzzled when you said that we need glue in the ontology, some sort of glue, but there's no nomic charge. But if, you know, the ontology comes together as a package deal with the laws, with the systematization, I don't see how you can even separate the question of ontology and the question of nomic charge. It seems to me then that the ontology and the nomic charge come as a package. I don't think it's a problem. I'm very sympathetic to your approach, and I think it's very promising. Don't get me wrong. I'm just a little bit puzzled why you insisted a couple of times.
So, insist is too strong for me. Okay. I see what you're saying. The reason it's in the back of my mind is something like this. I think the laws is very, very general and somehow universal, whereas these things say, look, if you, what you got to have is these kinds of connections between these particular things. And so maybe they're universal too, but I thought there might be a way of having a wedge, but maybe not, in which case that's fine.
Okay, we're out of time, so please join me in thanking